So let's talk about Newton's first law. So Newton's first law states that an object at rest will stay at rest, or an object in motion is going to stay at motion unless it's acted upon by an outside force. Now, when we think about this, we usually think of, I usually like to think of something like if we're in outer space. So if I've got this object, I've got this bowling ball, and I'm an astronaut, and I've got it out in space, and we just leave it there, it's just going to stay at rest. Or if I've got something on the table, I've got this thing of tape, and I leave it there, it's going to stay there. Unless something either pushes it, or I pick it up, or I get it knocked off the desk. But if it's in equilibrium, so we talked about, remember, the net forces acting on it are zero. You've got gravity pulling it down. You have the normal force holding it up. So those cancel each other out. So the net forces on this right now are zero. So if the net force is zero, nothing is going to change with this. Now, if I'm rolling it and it's slightly going through the air, now we're back in outer space. So there's no gravity, there's nothing else going on. This thing is just kind of floating through space. It's going to continue floating through space forever and ever and ever unless some force acts on it. Let's say it gets too close to a planet and it gets to its gravity, and all of a sudden the gravity that pulls it in, or it runs into something that's in outer space. So if it's in motion and there's nothing going to disturb it, it's going to continue like that. If you think of rolling a bowling ball down the lane, it's greased, there's very little friction. That thing has almost the same speed of when you let it go to when it hits those pins. And nothing happens to it until it either hits a pin or it hits the sides, the bumpers, if you're a terrible bowler. Anyway, but it's going to continue. So that is the first law of motion, Newton's first law of motion. An object at rest or in uniform motion will stay at rest or stay in uniform motion unless acted upon by an outside force. And again, remember, both of those situations, the net force is zero. So it's just moving on its own or it's sitting still. Something has to act on it to bring those forces, that net force, to be not zero any longer. So that's going to bring it out of equilibrium. Okay, well, anyway, continue on with the slideshow. There's some videos in here. There's some questions, and, do your best. And remember, science is all about thinking. It's not necessarily having the right answer. It's about thinking and finding an understanding of what it is we're talking about. So don't think, if I don't have the right answer, I'm not doing well. If you're thinking about it and you're building an explanation, you are on the right track. Okay? Keep going.